So another thing we can do with that confidence interval formula is we can use it to calculate the sample size necessary to get a particular margin of error. So thinking back again to that CNN poll, we could see there that that margin of error of 3.5%, remember that resulted in a confidence interval from 49.5 to 56.5%, which was not terribly useful because we had either the measure will pass or the measure will fail, and we really weren't able to make a conclusion. So we might want to say, well, instead of 3.5, what if we said we wanted our margin of error to be equal to, say, 2% or 1%? How many people would we need to sample? How many people should CNN have talked to? And so, well, in that case, we could go ahead, plug that in for our margin of error. If we know our confidence level and we have a prior p hat and q hat, we can throw all that in and we can calculate an n. So this formula is on your formula sheet under sample size for proportion. The hardest thing for students on this particular question is the figuring out what exactly is being asked for. And then there's two more little pieces that you want to have maybe on your note card. First one is if our p hat is unknown, we're going to use a p of 0.5. The reason for this is this is basically what our different sample sizes are given certain p hats. And you can see we basically have an upside down parabola, right? A parabola that opens down that has its vertex or maximum value at 0.5. And this also makes sense for those of you who are a little mathier. If you go through and look at this, we have p hat times 1 minus p hat all over our margin of error squared. If you distribute this p hat, you can see you'll end up with a negative p hat squared in that numerator. Obviously, there's a z star squared and a margin of error squared and all that stuff too, but this here tells us that we have a parabola that opens down, and we can even see that the zeros of that parabola are at 0 and 1, so the midpoint is at 0.5. So that's the math behind why it is that we're using 0.5. But you just need to know if we don't have an estimate, use 50% because it is the most conservative. It's going to give us the largest value. In fact, let's bust out that formula sheet and add that note to our formula sheet. So we're going to go to the formula sheet. We have this formula here, sample size for a particular n, sample size for a proportion. Let's just add a little note here. If p hat unknown, use p hat equal to 0.5. All right, so that'll be there. There was one other piece that matters, and I would dock you a point or two if you didn't do this properly, and that is, since we're going to be getting a number of people or a number of bags of potato chips, whatever the heck we're sampling, we do want to make sure we give this out as a whole number. And since we want to make sure we get out that margin of error, we're always going to take that number and round it up. So let's, in the next video, see exactly what this looks like.